T8.11. The U.S. Forest Service is considering additional restrictions on the number of vehicles allowed to enter Yellowstone National Park. To assess public reaction, the service asks a random sample of 150 visitors if they favor the proposal. Of those, 89 say yes. All right, so I'm just going to make some notes here. Sample size N is 150. The sample proportion P hat is 89 out of 150, which is the equivalent to 0.593. All right, part A. Construct and interpret a 99% confidence interval for the proportion of all visitors to Yellowstone who favor the restrictions. All right, so if 99% is the confidence level, then that would mean the z-score is 2.576. All right, so I'm just going to move these notes over here, and we can just make it a little bit smaller because we still need space to show our work. Okay. All right, now we want to use the 4C method to respond to part A, right? This is what the 4C method will ensure that your response includes everything that College Board is looking for. All right, so the first step is choose, okay? So we need to choose the procedure and state the parameter. I think you got to state the confidence level too. All right. So the procedure that we are going to use here is the one sample Z interval for estimating a true proportion. Okay. The confidence level is 99%, and the parameter would be the true proportion. Here, we'll just copy it. The true proportion of all visitors to Yellowstone who favor the restrictions. True proportion of all visitors to Yellowstone that favor the restrictions. All right, so that's step one. Step two, we've got to check our conditions. Okay, so first, the random condition, and I underlined it here for a reason so that we can just quote the problem. Okay, the service asks a random sample. All right, so check, we've met the random condition. The 10% condition, all right, so we're going to ask ourselves, is 150 visitors less than or equal to 10% of all visitors to Yellowstone? Okay, well, if you're not aware, Yellowstone is one of the more popular national parks, and they get millions, is it millions? I want to say probably millions, at least hundreds of thousands of visitors every year. Okay, so this is likely to be true. All right, the last one is the large counts condition. Okay, so here we want to check n times p hat is at least 10, and n times 1 minus p hat is at least 10. Okay. So that'll be 150 times 0.593, which that's just going to equal 89. All right, that's at least 10. And then we're going to have 150 times the complement, which should be 0.407, and that should be 5061. All right. If you're wondering how I did that in my head. So I just did 150 minus 89, right? If I know 89 are in favor, then 61 are opposed. It just has to add up to 150. Okay, anyways, both of these are at least 10, so we're good to go. We've satisfied all the conditions. All right, I want to move some things around, so let's move that over here for now, and let's move all that up. All right, so now we need to calculate. So usually there's 4 things that go into this step. The general formula, which is written in words, the specific formula, which is written in notation, the formula with the numbers plugged in, and then the actual interval. Okay, so I'm going to be a little bit lazy here, and I'll just abbreviate. So point estimate plus or minus the margin of error. Okay, that's the general formula. Okay, now the specific formula. Okay, I have it memorized. It doesn't need to be memorized. Okay, so there's your point estimate, p hat. Okay, why don't we do this? Split screen. All right, so there's our point estimate. Okay, the margin of error is the product of a critical value and a standard error. The critical value is just the z-score, and the standard error is that expression right there, square root p hat 1 minus p hat over n. Okay, now I'm ready to start plugging in some numbers. Okay, all my values are over here. We're just going to plug it in. So 0.593 plus or minus 2.576 times the square root of 0.593 times 0.407. So I'm just doing 1 minus that in my head to get the next value there, divided by 150. All right, now the rest of it I'm going to do off screen on my calculator. I'll compute the 2 endpoints of the interval. All right, so I got the following values after calculating it. I got 0.490 and 0.696. Yeah. All right, so the fourth and final step in our method here is the conclusion. Okay, where we simply just write our interpretation. Okay, so here's the template that we always use. We are blank percent confident that the interval from A to B captures the true context. All right, so our confidence level was 99%. The interval goes from 0.49 to 0.696. And the context, or the parameter here, that was the true proportion of all visitors to Yellowstone that favor the restriction. So I'm feeling lazy. I'm just going to copy and paste that. Of course, it doesn't fit. I'll put it here. All right. So we're 99% confident that the interval from 0.49 to 0.696 captures the true proportion of all visitors to Yellowstone that favor the restrictions. All right. So now that that's done, what's Part B asking? Based on your work in Part A, is there convincing evidence that more than half of all visitors to Yellowstone favor the proposal? Justify your answer. Well, I'd say there's some evidence, right? Because some of the values in the interval are above 50%, right? Talking about more than half, okay? But I would not call this convincing evidence because some values in the interval are still less than 50%. Okay. All right, so we'll say no, there is not convincing evidence because some values in the interval are less than half, meaning less than 0.5. Okay. Now, if our interval looks something like this, right? If it was like 0.590 to 0.696, right? That would be convincing evidence because every number in the interval is bigger than half. Okay, but as it stands, no, we only have some evidence, not convincing evidence.